It is time to start finding zeros of quadratic functions. They are also commonly known as the roots or solutions to quadratic function. And those are the points where x or where our function interacts with x-axis and when y value is equal to 0. So enough talk. Let me actually insert a coordinate system to show you how zeros look. So let's say we have a quadratic function like this. Once again, zeros or roots are the points where our graph interacts or crosses x-axis. And these points have an x value and y value equal to 0, or you can make f of x equal to 0. So they're gonna have some x value, but the y value is always going to be 0. So that's something we actually going to utilize when we start looking for those x values. And there is 3 main ways you can find solutions to your quadratic equation. We actually already covered one of them during factoring, and that might be the easiest and the fastest way to find solutions to your quadratic function if you're good at it. Okay, so let's consider the first function when we are going to utilize factoring. So in any case, we have to make our f of x equal to 0. But factoring will simplify our operations. So as always, let's start with our function. And to factor it out before we make it equal to 0, we're going to utilize AC method. So seems that a times c is -8, and our b term is +7. So it seems that these two numbers are going to be -1 and +8, right? They multiply to -8, and when we add them, they come up to +7. Okay, so let's rewrite our function using these two factors. So we get 2x squared minus 1x plus 8x minus 4. And now we can group and factor some things out. Okay, from the first pair, it seems that we can only factor out x, and we are left with 2x minus 1. From the second one, we can factor, I think, 4, +4, and we're going to be left with 2x minus 1. Let's factor it out again. And we have 2x minus 1 times x plus 4. Okay, so now we are going to make it equal to 0. And as you can tell, we are going to have two solutions that will satisfy this equation. So first, we have 2x minus 1 equal to 0. And then we have x plus 4 equal to 0. So in this case, we need to add 1 to both sides, and it's 2x equal to 1. Let's divide by 2. And it seems that x is equal to 1/2. In the second case, x, when we add 4, obviously, or subtract 4, we're going to find out that x is equal to -4. So we have two solutions, 2 zeros, 2 roots, done. The second case, we are going to use the quadratic formula that a lot of students dislike because it involves a lot of calculations. But for a person like me, who absolutely despises and hates factoring, quadratic formula is the way to go. So let's copy our function first. So in the second example, f of x is equal to, what was it, 2x squared minus 9x plus 10 plus 10 plus 10. Okay, So let me remind you of the quadratic formula. It is a big fraction divided by 2a, and on the top we have negative b plus minus, indicating that we are going to have two solutions, and then we have a big square root of b squared minus 4 times a times c. So let's start doing our calculations. First, let's label what is a, what is b, and what is c. And now we can plug everything into our quadratic equation, or quadratic formula, sorry. So negative b is 9, right, because we have negative sign in front, plus minus big square root, and b squared is 81 minus 4 times a, which is 2, times c, so 4 times 2 times 10, divided by 2a, which is 4. Now let's figure out what's underneath the square root. So 9 plus minus 81 minus 4 times 2 is 8 times 10 is 80, divided by 2a, which is, we already calculated that, which is 4. Equal sign again, and we have 9 plus minus square root of 1 divided by 4. So it's 9 plus minus 1 divided by 4. Therefore, x1 is equal to 9 plus 1. That's 10 divided by 4, or 5 over 2, or 2.5. x2 is equal to 9 minus 1, which is 8 divided by 4. That's 2. So once again, we were able to find 0 number 1 and 0 number 2, or root number 1 and root number 2. I prefer finding zeros using this method. Even though it involves a lot of calculations and you have to deal with a radical, I still think it's a little bit faster than trying to factor out and then make it equal to 0 and then solve two linear equations. I'm going to leave it up to you to decide which one you like better. Everybody has different strengths and weaknesses. Like I said, I despise factoring, but if you're really good at it, if you're one of those people who can see it right away, I recommend using factoring, because you can make more mistakes by forgetting a negative sign, or making some miscalculations when you're dealing with this radical. Anyways, the last way to find a zero, or it's kind of similar way to the first part, but we are dealing with a different way of expressing a quadratic function, and that's the vertex form. So let me actually quickly copy the formula or the function. So it was f of x equal to, was it positive 2 or negative 2? Negative 2 x minus 5 squared plus 5 plus 5. And just a small warning, most of the time when you deal with vertex form, you are not going to find whole numbers. And you might see in this example, we'll see what we end up with. But let's make it equal to 0 first. Negative 2, x minus 5 squared, x minus 2 I'm glad that I caught myself early in the process. And then we have plus 5. Okay, so the first step is to subtract 5 from both sides. And we have negative 5 equal to negative 2 x minus 2 squared. Now let's divide by negative 2. And we end up with positive 5 over 2, because negative over negative becomes positive, equal to x minus 2 squared. Now let's take a square root of both sides. So keep in mind that negative 2 squared is 4, but so is positive 2 squared 4. So we need to keep that in mind when we take a square root from both sides. So we will end up with positive negative 5 over 2 equal to x minus 2. Obviously, let me not forget the square root. And lastly, we need to add 2 to both sides. So it seems that our x will be equal to positive 2 plus minus square root of 5 over 2. So we can divide that into two solutions. And we can say that x1 is equal to 2 plus square root of 5 over 2. And x2 is equal to 2 minus square root of 5 over 2. And like I said before we started solving this problem, most of the time when you work with the vertex form, you're not going to end up with whole numbers. And that's totally fine. Be comfortable with expressing numbers as radicals, because you're going to see it a lot when you will be working with quadratic equations. So hopefully by now you are comfortable utilizing factoring and then making equal to 0 to find solutions of the quadratic function. You also should be comfortable with utilizing the quadratic formula. I particularly find it very useful, and when I was in school, that was my preferred method of finding x1 and x2 of any quadratic function. And lastly, if you're dealing with the vertex form, you're going to proceed the same way. You're going to make your function equal to 0, but you have to be mindful of this step. Okay? Whenever you take a square root of something, keep in mind that it becomes both positive and negative. Few more things I want to mention. Actually, one thing I want to mention. Not all of the quadratic equations or quadratic functions have a 0. And to show you a few possible cases of quadratic functions that do not have a 0. First case is a parabola that opens up anywhere in the coordinate system that does not interact with x-axis. We are not going to have any zeros. We are going to have y-intercept, but no zeros. Second case is a parabola that opens downward on the y-axis. So it's moved down by a few units and also no zeros. And the third case is basically different transformations of both. So they can be located anywhere in the quadratic, in the coordinate system. So that's one example. That would be a second example. That would be a third example of that. And lastly, let me do one in blue, looking like this. And also let me not forget to write no zeros. And trust me, if you're dealing with one of those, when you're looking for zeros, you'll find out that it has no solution, that such zeros do not exist. In the next video, we're going to practice everything we have learned so far about quadratic functions and put it all together. See you there.